Good morning, students. So in chemistry, last class I was discussed about the in states of matter. కొన్ని ప్రాబ్లమ్స్ చేస్తున్నాం. So now I will discuss about the molecular velocities. So what is the topic? Molecular velocities in states of matter. In states of matter. So last class చాలా సమ్స్ చేస్తున్నాం, నా ఆబ్జెక్టివ్ బిట్స్ చాలా చేస్తున్నాం. సో నా టాపిక్ వస్తున్నాను ఇన్ స్టేట్స్ ఆఫ్ మ్యాటర్లో. సో వాట్ ఇస్ ద టాపిక్? మాలిక్యులర్ వెలాసిటీస్. ఇన్ దిస్ మాలిక్యులర్ వెలాసిటీస్, త్రీ వెలాసిటీస్ ఆర్ దేర్. వన్ ఈజ్ ద RMS velocity, and second one average velocity, and third one most probable velocity. It is represented by the C. It is represented by the C bar, and it is represented by the Cp. Okay na? The molecular velocity, we are having the three topics in the molecular velocities, and first one is RMS velocity, and second one average velocity, and third one most probable velocity. And the first one, now I will discuss about the RMS velocity. So what is the meaning of RMS? Root mean square velocity. RMS means root mean square. RMS means root mean square. So what is the meaning of the RMS velocity? It is the RMS velocity is the roots of the mean of the squares of the velocities of all the gases of molecules at any temperature is called RMS velocity. Okay, so it is represented by the C. Okay, so it is the RMS velocity. It is the squares of, it is the root of the. So RMS means root mean square. So what is the meaning of the RMS velocity? And given the definition, it is the root of the mean of squares of squares velocities, C1 square, C2 squares, and C3 squares, and up to so on Cn square by mean is called root mean square velocity. That's the definition. So once again I will repeat it. So what is the meaning of RMS velocity? It is the root of the squares of the, it is the root of the squares of the mean velocities of all gases of the molecules present in the given temperature or any temperature is called RMS velocity. It is the RMS velocity. Clear? So what is the meaning of the RMS velocity? It is the root of the squares of the mean of the velocities of all the gases of the molecules at any temperature is called root mean square velocity. It is a mathematical, it is represented as C is equal to square root of 3RT by m. So we know the PV is equal to RT. మనందరికీ ఏం తెలుసు? PV is equal to RT అని తెలుసా లేదా? So we know the PV is equal to RT. So then it is RT is converted into 3PV. So 3PV by m. Okay, we know the density is equal to mass by volume. Here was volume by mass, then convert into square root of 3p by d. Okay, now this is the root mean square velocity. Here the PV is equal to RT and density is equal to mass by volume. And what values you say? See, we get the RMS velocity is equal to under square root of 3p by t. So finally, what is the value of the C ante? 1.58 into 10 to the power of 4 under square root of t by m. So how we get this value ante, here the 3 into, here 3 into r is a 8.314 into and the m value values మొత్తం సబ్స్టిట్యూట్ చేసి క్యాలిక్యులేషన్ చేస్తే 3 r వాల్యూ 8.314 into joules or x లో కన్వర్ట్ చేసిన తర్వాత the substitute the value in the r, we get the 1.5 into 10 to the power of 4 into under square root of t by m. So this is the final value of the RMS velocity. Okay nana? And next one, clear? RMS velocity. And next one, average velocity. And second one, average velocity. So what is the average velocity? It is the average of velocities of molecules of the all the gas at any temperature is called average velocity. Clear? What is the average velocity? It is the average of the velocities of the gas molecules present in the any gas at any temperature is called average velocity. Clear? Once again, it is the average of the velocities C1 plus C2 plus C3 and up to so on Cn by n. It is represented by the C bar. So that is the average velocity. It is the average of the velocities of the molecules of the gas any temperature is called average velocity. Average velocity. So it is mathematical expression as under square root of 8 RT by pi m. Okay, here R is equal to PV. Okay, an ideal gas equation, n is equal to 1, PV is equal to RT. So then convert into under square root of 8 PV by m. And next one, it is equal to the 8p by pi d. Here the volume by mass. Mass by volume is the density, and the reverse of the volume by mass is equal to 1 by d. So V by m is equal to m and d equal to 1 by d. Finally, we get the average velocity is equal to 0.9213 into RMS velocity. That is the final value of the average velocity C bar. C bar is equal to 0.9213 into RMS velocity. That is the average velocity. And next one. So what is the next one? Most probable speed, CP. Most probable speed, CP. So what is the meaning of most probable velocity? And it is the velocity is possessed by the maximum number of molecules. So that is called most probable velocity. So meaning most probable velocity. What is the meaning of most probable velocity? The velocity is proposed by the maximum number of molecules present in the gas at under conditions of temperature and pressure. We get the most probable velocity. So what is the meaning of most probable velocity? The velocity is possessed by the maximum number of molecules of the gas under conditions of the temperature is called most probable velocity. So Cp is equal to under square root of 2RT by m. So we get the 2PV by m. Finally we get the under square root of 2p by d. Clear? So RT is equal to PV and V by m is equal to 1 by d. So finally we get the Cp is equal to under square root of 2p by d. This is the most probable velocity. So finally that value of Cp, most probable velocity Cp is equal to 0.8166 into RMS velocity. RMS velocity. Clear? So once again I will repeat these three topics. First one, RMS velocity, that means root mean square velocity. What is the meaning of root mean square velocity? It is the square root of mean of squares of velocities of all the gases of the at any temperature is called root mean square velocity. Clear? It is the square root of the mean of the squares of the velocities of the molecules of the gas at any temperature is called root mean square velocity. Finally, it write the C is equal to under square root of 3 RT by m. Here RT is equal to PV. PV is equal to RT is the ideal gas equation. N is equal to 1. So 3 RT by m is equal to under square root of 3 PV by m. Finally, we get the under square root of 3 PV by D. So PV is equal to RT and density mass by volume. How we get the mass by volume by mass is equal to 1 by D. Mass by volume is the density. So volume by mass is equal to 1 by D. So under square root of 3P by T. So finally, RMS velocity of the value is equal to C is equal to 1.58 into 10 to the power of 4 into under square root of T by m. Substitute the value or we get the 1.5 into 10 to the power of 4 into under square root of T by m centimeters per second. Centimeters per second. And next one, average velocity. What is the average velocity? It is the average of the velocities of the molecules of the gas at any temperature is called average velocity. It is the average of the velocities of the molecules of the gas at any temperature is called average velocity. It is represented by the C bar. C bar is equal to C1 plus C2 plus C3 plus and so on plus Cn by n. So finally we get the C bar is equal to 8 RT by pi m and RT is equal to PV. So N is equal to 1 of the ideal gas equation and the square root of 8 PV by pi m. And finally we get the volume by mass is equal to 1 by D. So finally we get the 8 P by pi D. So finally we get the average velocity bar is equal to 0.9213 into RMS velocity. This value mattani multiply with the RMS velocity. We get the average velocity. And next one, most probable velocity, Cp represented by the Cp. So what is the most probable velocity? The velocity possessed by the maximum number of molecules. Emantunnanu velocity possess avutundi evariki maximum number of velocity is possessed by the maximum number of molecules of the gas under the conditions that is we get the Cp is equal to under square root of 2 RT by m and it is equal to 2 PV by m. Here the PV is equal to RT under square root of 2 PV by m. So finally we get the volume by mass that is equal to 1 by D. So we get the 2P by D. And Cp is equal to 0.8166 into RMS velocity. We get the most probable velocity. Cp is equal to 0.8166 into RMS velocity. Okay. And relation between these three velocities. Relation between molecular velocities. Relation between molecular velocity. How we get? That is the Cp is to C bar is to C. That is the relation between the molecular velocities. The Cp value చూడండి అన్న ఏముంది ఇక్కడ Cp is equal to 2 RT by m. 2 RT by m. And here C bar is equal to 8 RT by pi m and is equal to the 3 RT by m. 3 RT by m. So RT cancel. Okay, Nana. RT cancel. M cancel. Finally, we get the root 2 is to root 8 by pi is to 3 root 3. Okay. So finally, we get the 1 is to 1.12 is to 1.22. Okay. So 1 is to 1.12 is to 1.22. This is the relation between the molecular velocities. Relation between the molecular velocities of the three velocities. That is the 1 is to 1.12 is to 1.22. Clear? This is the molecular velocities of the RMS velocity, average velocity and most probable velocity, and relation between the molecular velocity is the Cp is to C bar is to C. Finally we get the 1 is to 1.12 is to 1.22. That is the relation between these three molecular velocities. Okay, Nana. And next one, E molecular velocity మీద we get to calculate the one sum. ఒక ప్రాబ్లం చేద్దాం దీని మీద, molecular velocities మీద. ఓకే, ఒక ప్రాబ్లం చేద్దాం నేను ఈ మాలిక్యులర్ వెలాసిటీస్ మీద. చూడండి, క్యాలిక్యులేట్ ఆర్ఎంఎస్ వెలాసిటీ, క్యాలిక్యులేట్ ఆర్ఎంఎస్ వెలాసిటీ, యావరేజ్ వెలాసిటీ, RMS velocity, calculate RMS velocity, average velocity and most probable velocity of SO2 at 27 degrees centigrade. At 27 degrees centigrade. Okay. Okay, Nana. So చూడండి సమ్ చూడండి ఒకసారి. Calculate RMS velocity, average velocity and most probable velocities of SO2 at 27 degrees centigrade. SO2 యొక్క RMS, average, most probable velocity ని ఫైండ్ అవుట్ చేయమంటున్నాడు. ఇక్కడ at a given temperature ఉంది, ఇక్కడ 27 degrees centigrade దగ్గర we find out the RMS, average, most probable velocities of the SO2. So first of all we find out the SO2. First of all we find out the SO2 molecular weight. So what is the molecular weight of the SO2? First of all we know the atomic numbers and atomic weights of the sulfur, oxygen. Oxygen atomic number in the 8 and sulfur atomic number 16. Oxygen atomic number 8, sulfur atomic number 16 and atomic weights 16 of the oxygen and 32 of the sulfur. Sir, here the find out the molecular weight of the SO2. Every molecule every SO2. So one sulfur molecular mass of SO2 equal to one sulfur 32 plus 2 oxygens, 2 into 16, 2 into 16 32, 32 plus 13 equal to 64. That is the molecular mass of the SO2. Okay, and a given data temperature is there is a temperature is equal to 27 degrees. It converted into kelvins. 27 plus 273 equal to 300 Kelvin. We know the R value. What is the R value? 8.314 into 10 to the power of 7 Eric's Kelvin inverse mole inverse. These are the data. You find out the RMS, average and most probable velocities. So what is the RMS velocity? First one, RMS velocity. What is the RMS velocity? And a square root of 3RT by and a square root of 3RT by m. Substitute the values. We know the R value, T value, m value. This is the m value and this is the T value and this is the R value. Substitute the values in the formula of the RMS velocity 3RT by m. So 3 into 8.314 into T is the temperature, that is 300 Kelvin, into 10 power 7. 8.314 into 10 power 7 by m is the 64. Okay, so we get the 3.42 into 10 to the power of 4 meters per second. Finally we get the 3.14 into the power of 4 meters per second, centimeters per second. Centimeters convert into meters, 342 meter per second. That is the substitute, that all values substitute in the formula. We get the 3.4 10 to the power of 4 centimeters per second. The centimeters convert into meters, 342 meter per second. Clear? And next one, average velocity. Average velocity. What is the average velocity? 0.9213 into 0.9213 into RMS velocity. 9213 into RMS velocity. 0.9213 into 342. We get the 315 meter per second. Calculation cheste we get a 315 meter per second. And third one, what is the third one? Most probable velocity. Most probable velocity. Most probable velocity, that is a 0.8166 into RMS velocity. RMS velocity, that is equal to 0.8166 into 342. We get the 279.27 meter per second. That is the calculation. We get the 279.27. That is the three values of the RMS velocity, average velocity, RMS velocity, average velocity, most probable velocity. Clear? Once again I will repeat it. Calculate RMS velocity, average velocity and most probable velocities of sulfur dioxide at 27 degrees centigrade. Sulfur SO2 అనే గ్యాస్ ని ఈ టెంపరేచర్ దగ్గర find out the RMS, average, most probable velocity. Clear nana? Sulfur dioxide ni at 27 degrees centigrade దగ్గర ఆ త్రీ వాల్యూస్ ని క్యాలిక్యులేట్ చేయమండి. Calculate these three values at 27 degrees centigrade of the SO2. Clear? So first one, we calculate the sulfur dioxide molecular weight, that is the oxygen atomic number 8, atomic weight 16, sulfur atomic number 16 and molecular atomic weight is the 32. So molecular mass of the SO2, that is the 32 and one is the sulfur is the 1, so 32 and 2 oxygen 2 into 16, that is the 32 plus 32 64, that is the molecular mass of SO2. And next one, temperature is given 27 degrees centigrades. It convert into Kelvin plus 273, we get the 300 Kelvin. And we know the R value. R is equal to 8.314 into 10 to the power of 7 X Kelvin inverse mole. Substitute these three values. In the RMS velocity. What is RMS velocity? It gives under square root of 3RT by m. 3 into 8.314 into 300 into 10 to the power of 7 by 64. We get the 3.14 10 to the power of 4 centimeter per second. Centimeters convert into meters, 342 into 342 meters per second. And next one we get the average velocity, 0.9213 into RMS velocity, 0.9213 into 342 RMS velocity. RMS velocity which in value, our value substitute in 340, we get the 315 meter per second. And next one, most probable velocity, 0.8166 into RMS velocity, 0.8166 into 342, we get the 279.27 meter per second. Okay, Nana? So today our class is molecular velocities, RMS velocity, average velocity, most probable velocity. And next one, వాటి గురించి చెప్పుకున్నాం. What is the RMS velocity? What is the average velocity? What is the most probable velocity? What is the RMS velocity? It is the roots of the mean of the squares of the velocities. Clear? It is the root of the mean of the square. R means root, M means mean, S ante squares. So it is the root of the mean of the squares of the velocities of the molecules of the gas at any temperature is called RMS velocity. What is the average velocity? It is the average of the velocities of the gas molecules at any temperature is called average velocity. What is the most probable velocity? The velocity is possessed by the maximum number of the molecules of the gas at a given temperature is called most probable velocity. What values చూసుకున్నాం, what relation చూసుకున్నాం. What is the relation of the three? 1 is to 1.12 is to 1.22. This is the relation of the RMS average most probable velocity. So వాటన్నిటి ఒక ప్రాబ్లం చేస్తున్నాం. There is a calculate RMS velocity, average and most probable velocities of sulfur dioxide at 27 degree centigrades. Clear? Okay, Nana? So tomorrow I will continue. Thank you, Nana.